So we're going to work on our graphs of our exponential functions today. So an exponential function is a function in which the independent variable appears in an exponent. Our general equation for it is y equals a times b to the x. So x is your independent variable. It is up in the exponent spot. So that's why those are exponentials. So for these where a and b are just numbers, they can be decimals, they can be fractions, they can be whole numbers, they can be integers. So then what happens with our exponential functions when we graph them is they have what we call an asymptote. So an asymptote is a line that a graph approaches, but it does not actually touch or cross that point. So what happens in your calculator is it can only round so many decimal places. So after a while, it kind of stops rounding, and it starts saying that the value is where the asymptote is, but it's actually not. It just has reached the limits of its capability. So you have to be able to figure out your asymptote based on the equations. That's usually the easiest way. So transformations of our exponentials, we did talk about transformations last unit also. But if you take a look here, if you are adding something at the end, so as you can see here, I have a plus 5 or I have a minus 5. If we were to type it in and graph it, it would look like this graph right here. So that transformation moves it up or down. So the plus 5 took my graph right here of 3x and it moved it up 5 units. And then the minus 5 took my 3x and it moved it down 5 units. So that plus or minus at the end, just like before, plus or minus at the end makes your graph move up and down. Same thing with your exponential. That plus or minus makes it move up or down. Now I don't have it graphed on there, but if you have something in with the x, so like x plus 1, x minus 1, it's in parentheses, attached to your x. That's the one that moves left or right. And remember, it's always the opposite of what you think adding. So x plus 2, that would actually move to the left 2 where you would normally think it's the right. And then the x minus 1 would move to the right. So you got to remember those ones are opposites. So your a value being out in front, there's a couple of things that could happen. If it's negative, this reflects over x-axis. Again, just like all of our other transformations we did in our last unit, you put that negative sign out in front, that makes it reflect over your x-axis. So then if you change the number out in front, so like here I have a 6, here I have a 1/2. So if you change that number out in front, that changes how wide or narrow it is. A number greater than 1 makes it narrower. So narrower when a is greater than 1. And then wider if a is between 0 and 1. So that a value changes a few things. You can reflect it, you can make the graph narrower, or you can make the graph wider. And then our last one, if your negative is right there with the x, so in this case our negative is right here in our exponent spot, that one reflects over the y-axis. So again, same transformation rules we have before, so we'll keep practicing them. So whenever you graph your exponential functions, you do need to make sure that you include your asymptote. That's always a necessary part of your graph. So here we're going to graph first y equals 2 to the x. So we'll do that on this first graph here. Y equals 2 to the x is what we're going to graph. So let's type that in our calculator under our y equals. I'm going to go to my y equals 2 caret x, 2 to the x. That's what we're going to graph first. So in looking at your table, you're going to want a couple of decimals and then the rest whole numbers. So I'm going to start here at negative 2.25. And then negative 1.5, 0, 1, 2, 2, 4, 3, 8, 4, 16. Now, I may not be able to graph all of those on my graph, and that's fine, but you can still put them in your table. So I'm going to graph first my 0, 1, because that's nice and easy to graph, so I always like to graph the easier ones first. And then I'm going to graph 1, 2, and then I'm going to graph 2, 4, 3, 8. And then as I said, 4, 16, that's not going to fit on the graph, so I'm not going to draw that one. Negative 1.5, so that means I'm only going to go about half a box up. And then 0.25 means I should be even closer to that x-axis than my 0.5 was. Again, you're going to just estimate with those two decimals. And then if we look at our calculator, there is the shape of our graph. It's that little curve to it. If you look, it kind of looks like it hits the x-axis right here, but it's not actually hitting it. The graph can't show you how close it actually is. So what you have to remember is because it looks like it's hitting the x-axis, that's your asymptote. So I'm going to draw that in first. That's our line we're going to get closer and closer and closer to, but it's never actually going to touch or cross it. And then connect your points. And that's our graph for the first one, y equals 2 to the x. So let's do the other one. They wanted us to graph y equals 2 to the negative x, which is the same as 1/2 to the x, because remember those negatives make fractions. So if I turn that 2 into a fraction, it would be 1/2. So it doesn't matter which one you use, as long as you use one of them. So I'm going to go to my y equals, go into my exponent, and change that to a negative x. So 2 to the negative x now. So if I look at my table, pretty much my table has kind of flipped right now. So I'm going to start with negative 416, negative 3, 8, negative 2, 4, negative 1, 2, zero, 1, 1.5, 2.25. And so then again, I'm going to look at my graph. Okay, my asymptote again is going to be on that x-axis, so I'm going to draw that in too. And then plot my points. 0, 1, negative 1, 2, negative 2, 4, negative 3, 8. So your graph should look exactly the same. The only thing is it's been reflected over that y-axis. So just like I said up above, That negative sign was with my x, so that's my hint that I knew it was going to reflect over the y-axis, and it ended up doing so. So both graphs include the point 0, 1. Because if you remember, 2 to the 0 is 1. 2 to the negative 0, which isn't a thing, but our equation had that negative sign up there, would also still be a 1.
Would the following students that are going to the college fair please
Alright, so as the x values decrease by a constant amount, the y values are multiplied by a constant amount. This amount is the constant ratio and is the value of b. Whatever you're multiplying by each time to get you from one term to the next, that is your b value. So in this first case, our b value here is a 2, because b, base, is what has the exponent attached to it. This base is also a 2, but remember it had that negative exponent, so you could say your base was a 1/2, and then it's to the positive x. So it's whatever you're multiplying by each time, that's your b value. So in y equals 2 to the x, each y value is increasing as you move from left to right on your graph. It's an increasing one. But in the other one, your y values are decreasing. Because those values are going down each time. So what is the equation of the graph to the right? So we have to figure this out. So first off, is this graph increasing or decreasing as we go left to right? Increasing. So that means it could be choice 2, where my b value is a 2 and it's not a negative exponent. It could be choice 3. It's not going to be choice 4 because of that negative sign right there. That tells us it's going to be a decreasing. And then choice 1, that's not even an exponential. So, not going to be choice 1. So now we just have to figure out where is our asymptote line. So let's see here. Here's our y-intercept at -2. So the one right below it at -3, that's where your asymptote line is. So it's going to end up being the 2 to the x minus 3, because that number at the end tells us where our asymptote is. All right, number 3, the graph of the equation y equals 4 to the negative x lies in quadrants, which ones? So let's put that in our calculator just to make sure. So we want 4 to the negative x. And then if we look at our graph, yep, that falls into quadrants 1 and 2. Right there, choice 2. Oh my goodness, it is. Well, that's a typo. I'll have to remember to fix that. So next they want us to describe the movement from the first equation to the second equation. So our first equation in A is just 3 to the x. The second one is 3 to the x minus 5. So what does this minus 5 do? Yep, down 5. So for B, we got the 1/2 x, and then it's 1/2 to the x plus 7. That plus 7 is up in the exponent with the x. So which way is that going to move? Left, yes. It's always opposite of what you think when it's with the x. So that one would be left 7. And then our last one here, we added this negative sign out in front. That negative out in front does what? X-axis. Reflect over x-axis. Negative out in front is always x-axis. If the negative was with x in the exponent, that would be over the y. So what is the equation of the asymptote of the equation y equals 7 to the x plus 2? Looking at our 4 choices, we can automatically knock off choices 3 and 4 because those are vertical lines. Being just x equals, those are vertical lines. Our asymptote is a horizontal line. So it's not those 2 choices. It's got to be one of the other 2 choices. So if you're not sure by looking at the equation, what can you always do? Put it in the calculator. So we'll go to our y equals 7 to the x plus 2. Look at our graph. It looks like it's hitting the x-axis, but remember that's because the calculator can't be that specific. So it's going to be at y equals 0. So then make a table and graph y equals 2 to the x plus 4 on the same grid as 2 to the x. That's over to the right. Okay. So 2 to the x is already graphed. They want us to do 2 to the x plus 4. Now because it has that plus 4, that tells me its asymptote is going to be up at positive 4. So I'm going to draw that in first. Just so I don't forget to draw it later. Then I'll go to my calculator, type in 2 to the x plus 4. Oops. Gotta remember to leave that exponent spot when you're doing your plus 4. So look at in our table, again, you want to have a couple of decimals, the rest whole numbers, so I'll start with negative 2. So negative 2, 2.25. Negative 1, 4.5, 0, 5, 1, 6, 2, 8, 3, 20. Again, we won't be able to graph all of those, and that's okay. So 0, 5, 1, 6, 2, 8, 1.5, 1.2. So once you plot all the points that you can plot, connect them and make your little curve. Arrows on both ends, label on there. So part B, how did our graph move? It went up 4. And then find the Y-intercept and the asymptote. All right, so where's our Y-intercept of the one that we drew? Yeah, 5. The Y-intercept is at 5. You can write it as y equals 5 if you want to, or you can just state 5. That's fine. And then our asymptote line, that dotted line we drew in, that is a line, so you do have to write it as an equation, so that one is y equals 4.